coffee break. Now I would like to introduce you a very precious person, Professor Jaak Panksepp. He is the father of affective neuroscience, and in line with his theory, he is always in touch with his own affects. That's why I call him the grandfather of our society of neuropsychoanalysis. He is a family person. And today he is going to talk about the emotional foundations of mind and it in affective neuroscience. So, Professor Jaak Panksepp.
Well, thank you everyone for coming and inviting us. It's a delight to be here in this crossroads of culture and ideas. That's the second time I've heard Marx talk along these lines. The first time was the New York Psychoanalytic Society. Which month was it last year? June.
December.
December, okay. So just half a year ago. And I'm still thinking about how my ideas and his ideas are integrating very nicely. And I think someone reflected that this was a confusing talk. But of course, when ideas are brand new, they are always confusing. That's the nature of our minds. And it takes us a long time to get acclimated to the fact that reality is not the way we often think it is. We just have to think about the flat earth society and how long it ruled before the obvious conclusion was that the earth was not the center of the universe. And that perhaps our higher minds and our higher thoughts are not the center of our minds. So let me just briefly say how I got to this point myself. It was because I entered graduate school in clinical psychology in 1965, and I was dissatisfied with just behavioral modification and no conversation about emotions. It was taboo. You were supposed to bite your tongue when that word came to your mind. And it was rather boring. But I had the good fortune to be placed in a hospital since I'd worked in a back wards of a psychiatric hospital for a couple of summers and became very intrigued by the passions of the mind gone astray and thought that I wanted to get into that area. But clinical psychology was not the way to understand emotions in those days. And I realized rapidly that the only way to understand these mysteries of the mind was to go to neuroscience and to take an evolutionary approach. So the evolution of mind really is not a scientific topic at this point, but perhaps with a few lessons from Darwin, it can become that. And I think neuropsychoanalysis is really at the very forefront of looking at the evolutionary view of mind and how it interacts with the higher parts of the brain that emerge so rapidly in evolution, very similar to our laptop computers, desktop computers. When I was a young professor, these things did not exist on our desks. We had to use calculators, electromechanical calculators, a computation that now takes, microseconds inside the computer. Took my brain and my body days of punching in numbers and when the magic of the desktop computer came, it was a poor semblance to what we have now. But the operating principles are pretty much the same. What has been added is software, more random access memory, empty memory space like the cortex when we're born. That's a good analogy. I think John Locke was right, that the mind, the upper part of the brain at least, is largely tabula rasa before it confronts culture, real life, and all the variety of challenges we face. So it has to be programmed, and has to be programmed by life values, the things that we call emotions and affects and feelings that none of us learned to experience. It was just handed down to us by evolution. So I decided to go to the other animals, and this is the most recent painting I bought from a friend artist. And some people in the human sciences say, "Oh, you're the rat guy, aren't you?" Well, no, I'm not the rat guy, but I am the first one to make a rat laugh. And we learned that rats are ticklish, and maybe I'll be able to show you a segment of a video from just 14 years ago, about 6 years after we discovered the phenomenon. So I've worked on a lot of the intermediate animals and a lot about the birds up there. So, lots of species, but a lot of our work on the social brain started with dogs, and dog would have been a wonderful subject to study the social brain because we can be in their social networks, we can be part of their families. What a wonderful location to be in. And we were the first to bring John Bowlby's ideas about depression and importance of child experiences into the neuroscience laboratories in the 1970s. And we had the first theory of what the neurobiology of social attachment was about, that it was an addictive process that operated through those recently discovered brain opioids. And it's been kind of forgotten in the past 20 years, but it will come back as people begin to face reality and realize that oxytocin is not the love molecule. It is a very important molecule. It mediates really important behavioral and psychological things, but I don't think anyone has really chosen the right word, the right symbol to discuss what it does. We know it's a subcortical system almost completely. It's ancient. So this molecule that is captivating so many people as doing everything wonderful socially certainly is a big player, but we don't even have the right word for the game it's playing. And I think the tune it is playing is something along the lines of motherhood, what motherhood requires in order to bring up a child. And certainly it requires a lot of work and a devotion. But the one thing it needs more than anything else is courage. Courage to take that enormous transition. A mild word for courage is confidence. So we think the molecule actually increases confidence. And when you have social confidence, you can have lots of interesting and powerful social networks, as mothers can create, because they have to rely on others to help out. So mothers and others, as Sarah Hardy wrote a wonderful book. Anyway, opioids are a bigger part of attachment in general than oxytocin, but we haven't learned that lesson yet. But I'm very appreciative that the clinical sciences have found this book and the psychotherapeutic disciplines have found this book more useful than I could have ever hoped for. And I certainly appreciate it, because this was written for the people that care about the mind, and the mind that has become imbalanced through the vicissitudes of life. But I had to go to the animals in order to learn about the human mind. And of course, if you take an evolutionary approach, there really is no other way, because we cannot study the details of the mechanisms. So how much do we really share with the other animals? Well, this book will be finally coming out, The Archaeology of Mind, and it probes the emotional aspect of life with the same organization as affective neuroscience, but it brings in some other dimensions, but not all the wonderful dimensions that Mark just highlighted. You know, how this lower part of the mind, the biological foundation of consciousness, we know that for sure, how it brings about the higher forms of consciousness, some of them quite spontaneously, like perceiving the object field, to the point of having very complex ideas about the object field. How all that comes about, the science really does not exist, so we can only have working hypotheses. And I think the ideas that Mark shared are about the best working hypotheses I have heard at that level. So, what did Darwin say? He said, among mammals, our mental differences are one of degree and not of kind. Certainly they can't do calculus, but we didn't have any biological disposition to do calculus ourselves, nor to write, nor to read. All these things are cultural inventions. You know, all the music that we play with instruments, they are cultural inventions, but none of them would have much value unless they moved our emotional feelings. And we do share the basic emotional feelings with all the other mammals. And for the first time, the other mammals will teach us who we really are if we study them carefully and we're open to their experiences. But we're not, as a science, yet open to their experiences. Even the most sensitive people that do animal welfare research, for instance, Marion Dawkins, just came out with a book, Why Animals Matter, Oxford University Press. And she basically says we cannot go to the experiential level. Subjectivity cannot be studied. It simply is a belief. And I choose to disagree, because I would not have gotten into this field almost half a century ago unless I believed, and then it was a belief, that the other animals actually do experience their emotions. I would not have wasted my life unless I had that belief. And now the evidence is enormous for that conclusion, but it all comes from neuroscience. All of it. Without the neuroscience, it's truly belief. And Marion Dawkins has not recognized this aspect, so I will have to write her again. Hopefully more gently this time than last time, about 5 years ago. So Immanuel Kant said concepts without facts are empty. And obviously Freud had to work at a conceptual level with deep intuitions about how the mind was organized, primarily from his own life, but also the lives of people that he was trying to help. Of course, there had to be some errors there. And there are errors in my work that I do not yet recognize, and I will be chagrined when they're pointed out to me. And I hope I'm mature enough to say, yes, I was wrong. Facts without concepts are blind, and we are in an era of massive fact collection without the capacity for fact integration. Often the facts are collected without any real deep question about the brain. The technology has run in front of us, and the metaphor you can imagine, the picture you can imagine, is a brickyard in chaos. Even the bricks aren't well organized. There is certainly no structure like the wonderful mosques in this city. So my only concern my whole career has been the nature of primary process emotions and the feelings they generate. Especially the emotional affective feelings. There are other kinds like sensory feelings, bodily hungers and thirsts. And I've studied those, but those are harder to understand neuroscientifically because they do not have instinctual action patterns that can anchor your analysis. The sensation comes in and we might smile and feel pleasure in our heads, but there's no unambiguous behavioral instinct. Hunger and thirst have similar problems. Emotions do not. The emotional actions are actually genetically organized in the brain because we can activate them by stimulating specific parts of the brain with wall current. Just energy into the brain produces an angry animal and a variety of other emotions. That means that the integration is built into the nervous system. Garbage in, garbage out is the rule of our computers. But the brain, you can put electrical garbage in and get coherence out. So just to finish the story of affect in 2 sentences, the reason we can conclude that there is an experience in that internal state that is in the general ballpark of the things that we call emotional feelings is that wherever you produce the instinctual action, it will serve as a reward or a punishment in simple learning tasks. If the animal did not have any experiences, the prediction would be, it's just a puppet. It's just a simulacra like you see in the movies. There is no mind in there. That would be the prediction. The animal would not care. It's just like a knee-jerk reflex. That's what most people assume the animal brain is like. But there's a law. Wherever you produce an emotional action, you will produce a reward or punishment. Does anyone here have a reward or punishment in the external world that they do not experience affectively? Pretty hard to think of one. We should not see ourselves as a special creation. Okay? Because we know these rewards and punishments arise from brain areas we share with the other animals. That single fact allows us to say the other animals are conscious creatures. They experience themselves in the world. And that can guide us into the analysis of the primary process emotions. One simply asks how many instinctual displays can be activated by garbage in, coherence out. And the argument is, right now we can defend 7. It's an open list. You can add more, but you should have evidence of this kind. The most ancient one is the brain reward system, which is just one of many rewarding systems in the brain that Olds and Milner discovered in 1954. This system, when you just stimulate it, produces the fixed action pattern of looking for resources. Exploring, moving around, sniffing, the world all of a sudden becomes a very interesting place. This system is probably deficient in depression, especially anhedonia. You simply don't have the psychological energy to go into the world creatively. And therefore, one of the targets of medicinal development and psychotherapy and somatic therapies should be to enliven the seeking system, which is not producing a feeling of pleasure, is producing a feeling of being in the world mentally alive with enthusiasm. So it's a very different view of my field of behavioral neuroscience that does not tolerate talk about animal emotional feelings. So I was going to show this Mark Hauser, the guy that just got thrown out of Harvard a couple of years ago for being a bit of a scoundrel. He said, here's what distinguishes the mind. First step in figuring out how the human mind arose is determining what distinguishes our mental processes from those of other creatures. It's just the reverse. The first step is understanding what we share with the other creatures. Then you add what's unique. What's this backward business? He said we have mental symbols. Well, that's basically verbal encoding of sensory experiences, language. So we generate funny concepts, generative computation. Everyone will have a different association to that. We have limitless ideas and concepts. However rich our imagination is, we can go there. He says promiscuous combination of ideas. Well, it's mingling domains of knowledge. He said we have abstract thought. It's contemplating images within the mind. So neuropsychoanalysis at some point will have some studies as to how the mind's eye works. It's possible the mind's eye is blind. Okay? And we have the illusion that we are seeing something when we're actually experiencing something affectively with a mind's eye. I feel this way about that. So that's a kind of Darwinian bottom-up approach. And in neuroscience, we have to take bottom-up approaches that very few people are taking. We also have to take a top-down approach, which 99.9% of people are taking. If you don't get the bottom-up right, you're going to make mistakes with the top down. And I think Mark highlighted humbly how one of his heroes made a dramatic core mistake as far as the evidence is concerned. But still, Sigmund Freud was in the right ballpark. He said no knowledge would have been more valuable as a foundation for true psychological science than an approximate grasp of the common characteristics and possible distinctive features of the instincts. But in no region of psychology were we groping more in the dark. And we're still there, okay? Because we have not recognized the instinctual nature of the human species as fully as we need to. Evolutionary psychology is trying, but it's just so stories about higher mental processes. And they're making so many mistakes, and there's so many of them, it will take generations of correction that may take, if we're like the human species of the past, hundreds, if not thousands of years. So we wrote The 7 Sins of Evolutionary Psychology in 2000. It's available on the web. Affect comes in various forms. They're presumably the evolved tools for living. They anticipate the future. That's why they probably involved. They intrinsically anticipate the future. And the good feelings tell you, do more of it because that will help you survive. Bad feelings tell you, do less of it because they are going to destroy you eventually. Simple enough. A child can understand it. But the feeling component was taken out of the conversation about animal learning. A tragedy that's lasted a century and continues. These guys are these affects that anticipate the future. They're the ancestral voices of the genes. Hunger is your friend. Thirst is your friend. Pain is your friend. Because if you alleviate them, you will survive. It's anticipating the future. Very hard to imagine just behavior anticipating the future. You need general principles, and maybe that's what consciousness is about. The general affective principles that every organism with a complex enough nervous system, we don't know how complex that has to be, that allows you to feel into the future. The pleasures and pains of sensation, I think, are harder to study than emotions. They have no fixed display. So you don't know exactly where to go in the nervous system to ask, is the circuit rewarding or punishing? Homeostatic drives, the hungers and thirsts. We know approximately where they're situated, but they're also harder to study affectively. The primary process emotional affects have action systems. ESB, electrical stimulation of the brain, can arouse these circuits. The same brain stimulation can motivate operant learning and condition place preferences and condition place avoidances, rewards and punishments that are the gold standard of consciousness studies at the primary process level, namely the hard problem of consciousness. Okay? Not the easy problems. There's plenty of correlates there. But the constitutive nature of consciousness, which is called the hard problem. I think there's been progress made on the hard problem for 40 years, 50 years, but it hasn't been recognized because emotions were thrown out by the cognitive revolution, by the behavioral revolution, and so forth. So the animals lost their feelings in the 20th century behavioral neurosciences, and they were substituted by ruthless reductionism, which means mind does not count. Experience does not count. It's just molecules and circuits and behaviors. The objective things, subjectivity, doesn't exist. It's a delusion, illusion. I think that is fundamentally incorrect, and neuropsychoanalysis is trying to reverse that in the human sciences. So stimulus response behaviorism finally had to survive, and they became neuroscientists, and therefore they carried all their biases into my field when I was a young professor. I saw it coming, and I said, what is happening here? These guys are still there. Cognitive science was supposed to kill behaviorism, but it didn't kill the behaviorists. So, to this day, I'm still having arguments with these guys. One of my friends says, Jaak, why do you continue impaling yourself on the horns of a dilemma? And I respond, Don, it's because I love to impale myself on the nature of reality. Well, hopefully it is. So we have to bring psychology and basic psychology into the discussion. No, for them, it's this spooky kind of thing like in particle physics. What is this? Well, people call it the Higgs boson. The super collider, here in Europe, is setting up experiments to finally visualize this theoretical entity that's never been seen, the Higgs boson. People call it the God particle. Some are even looking for consciousness at this level, quantum consciousness. Stuart Hameroff at University of Arizona, I think he is flawed in his thinking that there is mind dust in the universe. I think mind actually emerged with neural circuit functions. In any case, the latter is testable, the former is not. So, here's the guys that made assertions about the nature of the universe. John Watson gave us radical behaviorism, terrific techniques for learning and memory. And learning and memory is totally unconscious. That's where the unconscious truly resides, and it passes that message on to higher parts of the brain and automatizes our behavior. Affects, as Freud said, are never unconscious. The ethologists also were timid because experience cannot be observed objectively in animals. It is idle to claim or deny their existence. That bias comes down to us through Marion Dawkins, who just wrote that book I mentioned earlier, came out a month ago, Why Animals Matter. Animals don't matter because they experience the world. They matter because they also have preferences in the world. That's it. Let's not talk about experiences. That's cheap talk. It's not cheap talk because there's a lot of research, causal research, supporting it that she ignored completely. So again, different fields being isolated from each other. And anthropomorphism is bad, and I'm accused of giving animals human emotions. I'm sorry, what I'm trying to do is give animal emotions back to humans. That's called zoomorphism. They do. And the conclusion is not a belief statement. It is empirically based by the simple fact that wherever you activate an instinct with brain stimulation, that brain stimulation is rewarding or punishing. Wow. That's lawful relationship that doesn't appear in any textbook of psychology yet. We've had the knowledge for 50 years. So we all hate and we love. So who's going to give an answer? Descartes gave us this funny answer. Spooky, two fundamental substances. We build large buildings for this substance because they presumably fill the universe. There is God dust everywhere, as Spinoza said. And Spinoza said, no, there's not two things, there's one thing. And that's the approach that Mark and I have following with dual process monism, dual aspect monism. That reality has several different faces. They look contradictory, but in fact, it's our limited perceptual capacity. They actually emerge from the same process, like particle images of matter and wave images of electromagnetic radiation. So Antonio Damasio, Joe Ledoux were cognitive neuroscientists interested in motion. There were those in the behavioral realm and the affective realm. The middle group said feelings are irrelevant. We can throw them away. These folks were like Freud, saying feelings are neocortical, and these folks were saying feelings are subneocortical. One can note that Antonio Damasio has moved from here largely to here without giving up the recognition that, of course, the top of the brain does many interesting things for our emotional life. Of course, that happens. So what affective neuroscience tries to do is triangulate between mind, brain, and behavior, especially real behavior, which is built-in behavior, instinctual. And that's had a troubled history, but that's what the evidence indicates. When we produce those instinctual responses like rage or fear, very clear behavioral indicators, and you ask the animal, do you like that state? The animal says, no, I don't like that state. Other states like seeking and searching, lust, sexual behavior, maternal care, and playfulness, the animal likes those and turns them on. So, let's face reality. And I faced reality just a year ago in Austria. These are pictures from the wolves just 30 miles north of Vienna. And when you look into these creatures' eyes, and there's no fence between you, your mind does interesting things. And the interesting thing I had with this wolf was, I wonder if that wolf cares for me at all. So I asked Kurt Korderschall, who's in the red shirt here, would he kiss me? And he knew what I was talking about, and he lifted this dog onto the examination table because he said it's nice if you approach from below like a young wolf cub and just slowly approach your face, and whoosh, the next second the tongue ran over my face. Ha! The experiment was successful. He knew I wanted to interact, and I was hoping that he wanted to interact in a friendly way. But he was ambiguous, and believe me, my mind was full of ambiguities. And his brain was doing something interesting. Look at that piloerection. If I would have seen that, I would have been more hesitant. But we both had our behaviors that could be objectively studied, and we also shared a mind that we should call the brain mind. It's a unified field. We should not dichotomize like Freud. Freudian slip. Descartes. So, the heart of our emotional life is farther and farther down in the brain than most people believe. Amygdala can be gone. Guess what? A person without two amygdala is full of rich emotional things, but they're awfully trusting and nice people. Okay? They don't get anxious too easily. But they are full, vibrant, emotional people. But if you lesion the whole periaqueductal gray, as Mark mentioned, and you have to lesion all of it, from the mesodiencephalic junction to the pons, which was done in the 40s, in primates and cats, and the lights were out. Okay? These famous experiments by Bailey and Davis have been forgotten. 1942 and 1943. Something more important was going on in those years. All the emotional systems seem to converge here. So that is required for consciousness. It's also required for organismic coherence to behave in the world. There are columns, specialized columns, and interconnections, and a lot of great work, but the notion that it generates emotional feelings is not always recognized. Looks like something happened to the screen shifting, but the lowest brain stimulation produces coherent emotional changes here. Lowest amount of energy, and it's rewarding or punishing. The smallest amount of brain damage compromises consciousness. It's one of the best places in the brain to precipitate depressive cascades with brain stimulation. So we're doing animal models of depression, not by stressing animals with all these horrible things we can do to them. We're taking the relevant negative emotional systems and activating them and hoping we get a depressive cascade. Now we're bringing the models to an affective circuit level. And we do have a new antidepressant in testing right now in America that came from studying happy circuits in rat brains, looking for happy social positive affect promoting molecules. And it's in phase 2, namely proof of concept testing. Maybe I'll get to that point. In 1982, we had evidence for a seeking system, fear system, which was punishing, a rage system that was punishing, a panic system that was punishing. The seeking system was rewarding and very tightly related to this seeking. People call it the reward system, a very wishy-washy concept. Lust requires that system that's rewarding. Care, it requires that circuit. The circuit is rewarding. And play also requires that circuit, but it's probably different neuropeptides grabbing the system into slightly different neurodynamics. So the neuropeptides provide specificity for emotional responses. Things like glutamate and GABA are the very foundation of the mind. They're the skeleton of the mind. You have no mind if you take all the glutamate away or all the GABA away. It's just gone, especially glutamate. Just think where these molecules come from. They come from intermediary metabolism, directly. What differentiates life from non-life? Metabolism. Non-living things do not metabolize. The primary skeleton of the mind emerges from the metabolic furnace of our bodies. Glutamate comes directly off the Krebs cycle. It is converted to GABA with GAD, glutamic acid decarboxylase. One step from the most important excitatory amino acid that participates in every emotion to the most prolific inhibitory transmitter that also inhibits every emotion. And from that skeleton, you have to bring different emotional patterns, dynamics out. We don't know how that occurs, but we know where to look. We know where the circuits are situated. So this book tries to summarize that. And Ken Davis, who's here, and I generate this affective neuroscience personality scale and eventually published it in Neuropsychoanalysis. An updated form of the scale was published last year, and it's available free for use. It's been translated in 12 languages, and Koçya was responsible for doing the Turkish translation, and some of the most interesting research on the topic is occurring here. With cross-cultural studies with Japanese colleagues that are here, hopefully materializing very soon. It takes these emotional systems seriously and tries to analyze them with higher brain processes, namely language. Of course, that has to be an estimate. There's no direct measure of these systems aside from instinctual behaviors. And we left out one. We also call the panic system separation, distress, sadness, because people understand it better. We left one out, which is a S word, sex, lust, because we didn't want people to get nervous about it. But we're gradually adding that and some other possible candidates like dominance or power. But we put spirituality there because that kind of subtle dimension is very important in the psychotherapeutic disciplines and the 12-step programs for drug addiction, because 12-step programs is psychotherapy in the raw. People sharing their lives with each other who are totally accepting. What a rare moment. The only other time you have that moment is in psychoanalysis, or if you're lucky enough to be married or friends with someone that is willing to listen to your life as it really is. So let me just focus on the two systems that were not on the intellectual map at all when I was a student. Joy, which is playfulness, and sadness, which is we call the panic system. And here we run into the problem of language. We have different meanings for some of these emotional terms. And since we wanted to go to the primary process level, we had to select new scientific terms. And instead of separation distress, we call it the panic system. Instead of joy, which is reflected in social play, we call it the capital play system. The capitalization of a system indicates we're talking about a neural circuit that is instinctually organized in the brain and does have rewarding and punishing properties. It's as simple as that. Since that level of the brain and mind was not really studied by anyone intentionally before I started, and it was a surprise to me, and continues to be a surprise to me, that the neurosciences are not studying the very foundation of the mind, which is, at least in part, these kinds of systems, and incredibly important for psychiatry, psychotherapy, and the human helping disciplines. Now, when you have this happy expression, you also have a happy mind. The two go together. That is dual aspect monism. The instinctual, behavioral, and the action system go together. And a lot of people are not accustomed to thinking of experience within motor systems. But of course, these are not just motor systems. They are psychomotor systems. They are inside the brain. They're not just going out into your somatic and visceral musculature. They do that. But they have an integrated structure inside the brain that probably actually constitutes the core of the organism. At least that's the hypothesis. So we taught people in this paper that we published a couple years ago to laugh and to cry and to walk in their minds completely. Okay? Because we wanted to do brain imaging on the feeling of laughter, the joy, and the sadness of crying. And fMRI does not tolerate any movement. So we had to train people how to laugh in their minds and to cry in their minds and to walk in their minds. And what you do is you take young students who are open-minded in a laboratory practicum and you train them to do the motor actions of laughter and the motor actions of crying and the motor actions of walking without any noise so they don't disturb each other, and to practice at home and then evaluate whether they can transfer that motor dynamic into motor imagery. We already knew that the action pattern of laughter and crying makes you happier and sadder. Okay? Now, what do I mean by that? Laughter has a certain rhythm. You really hear something good, and you... No one will mistake that for crying. And I'm not about to cry in front of you. I had too much of that. This is now the motor imagery of people just imagining laughter and crying. This is measuring sadness ratings. When you laughed, the sadness ratings went down significantly. They're low to begin with. The crying elevated sadness ratings, and walking imagery did not change it. Okay? Now you can do fMRI. What about the happiness ratings? Shifting colors to a happier color. Maybe that's where color comes from. Remember, color is an invention of the brain. It's not out there in the world. What is the sound of one tree falling? in the forest when there's no one there. There is no sound. There's just air pressure. The brain creates the sound. These are inventions of the brain. Same for color. Maybe color are different frequencies, resonant frequencies of the various emotions. And that's why colors carry emotional feelings. In any case, when people laughed, they were more happy. And when they cried, they were less happy. And when they walked, it didn't make any difference. So, this stuff, I think, has psychiatric implications. And we're going to focus briefly on the face of tragedy and the face of joy. Separation distress, we think, is the foundation of the psychological pain that leads to loneliness and grief. But in its primal form, we gave it the word panic because the theory is that the panic system, the separation system, generates panic attacks. We know it's a separate negative affect from anxiety of the fear type. There are two separate anxiety type systems. The panic response is treated with different medicines than generalized anxiety disorders. And all the medications that are effective in panic attacks are pretty good in reducing separation distress. But the fear molecules are not, like benzodiazepines. They're not very good for reducing separation distress. So here's what a human separation call looks like. Here's our mapping of the system with electrical brain stimulation, and then Damasio did the first imaging of sadness using PET. And we were delighted that it had a very similar geography. What's that E about? Just floating around. Okay, we made the postulate that attachment was based upon the chemistries that reduce psychological pain. That's pretty simple. The first molecule were opioids, really powerful at incredibly low doses, and they were the only medicine in psychiatry before the revolution in 1954 with Thorazine and antipsychotics. And remember, every medicine used in psychiatry was discovered by chance. No medicine has been produced by human knowledge to this day. What have we done wrong? My answer is simple. We have not taken the emotions of the animals seriously that are required to understand the details of these systems. Simple, but no one is pursuing that strategy yet beside us. So, the opioid system was published in 1972-73. That year we started doing separation distress work. And we brought this knowledge to bear on autism issues. I won't talk about it since Brian is going to touch on those topics. But the similarities between opiate addiction and social dependence are enormous. There's a attachment phase, and then the attachment feelings run away. You become estranged and separated. And then even if you don't seem to like each other all that much anymore, if the other one is gone, there's usually withdrawal and separation distress. And the symptoms of opiate withdrawal are very similar to the symptoms of separation distress. So people and animals probably seek opioids to alleviate their psychological pain. Most addiction is self-medication eventually. In the beginning, often it can start other ways, but for many people it starts as self-medication. They can get emotional homeostasis via a molecule as opposed to human relationship. Jacques Cousteau in France, a playwright, said the reason I take opioids is because then I don't have a need to sit around in circles with other people. They can be alone. Here's how dogs responded to opiates. Morphine at tiny doses. There were different breeds. These were beagles, more sensitive than Tolomians. Tiny doses could eliminate the separation call. At these doses, the animal plays more. Okay? Because it's so socially confident. It's one of the few molecules we've found that can increase playfulness. So opioids were very powerful. Oxytocin is very powerful in reducing this separation call, and prolactin also. And you can see the evolutionary picture. The molecules of motherhood are the molecules of social attachment. How else would evolution design it? It's almost like later you say, oh, that should have been a no-brainer. And not too many molecules are very effective in reducing this. Most psychiatric molecules are very weak effects compared to these three. Here's prolactin and oxytocin across a 2-hour period compared to controls. Here's the circuitry again. And we know that human depression and human sadness are low opioid activity in this type of circuitry in the brain. That's done with positron emission tomography with radioactive carfentanil. The pleasure of touch is partially opioid. If you take a little bird that's all alone and peeping away and lonely, and you pick it up and you just put it in your hands, the animal gradually falls asleep within half a minute. It's comforted. If you block the opioid system with naloxone, the animal takes much longer to show comfort. It eventually does. There's many other molecules, but opioid release is very intense. And we know from other work that when monkeys are grooming each other, lots of opioids are released in the brain. So they're getting attached to each other. The only animals that don't show release of opioids are those that do not want to be groomed, because they already are dominant and they have lots of opioids in their brain. If I have plenty of comfort, why should I have you picking my skin? And an animal that has lots of opioids is usually the dominant animal in a primate society. And we can control social dominance by manipulating the opioid system in rats. Now, I won't show you that data, but it works beautifully. So, how about the other side, joy? Well, it's the same slide I transferred over. By studying joy, by looking at animal play, we eventually found laughter. And the laughter circuitry has been a gateway to new medicinal development. The antidepressant that I might get to was discovered by tickling rats, basically. And this kind of vocalization is very high when animals are in the midst of rough and tumble play. You will not find a situation in the world, natural world, where these chirpy little sounds are higher than they are doing rough and tumble play, chasing each other. And then it took us 6 years to say, maybe that's laughter. And I said, let's go tickle some rats. And my grad student came with me, and we tickle rats, and we're still tickling rats 16 years later. It's the first psychoassay in animal, an emotional psychoassay, where you have a validated circuit. Wherever in the brain, you tickle the brain and get a chirp. The animal turns that current on. It likes it. It's rewarding. And we were looking for molecules that shifted that upward. So let me shift forward, not show you that data that I just summarized in a couple of words. And go to this study where we looked at we looked at 1,200 genes about 8-9 years ago with microarrays, and we decided to focus on the cortex, where we knew there was all this tissue that was not needed for play. We could surgically eliminate, and play was totally normal. The animals were just as competitive with other animals without the cortex. And we said we knew that most of the neurons were activated by play in the cortex using CFOS, immunocytochemistry, indirect marker of neuronal activity. And we said we want to know the gene expression patterns. We looked at 1,200 genes, 1 hour and 6 hours after half an hour of totally happy play. No bad sounds were made, just happy sounds. So we had happy brain areas that lead to thoughts, cognitions. 1/3 of the genes were modulated either up or down in the front of the brain, frontal cortex, or posterior cortex. 38% overlapped the two areas. So if we're looking for a target for drug discovery, we have to target those intervening, overlapping ones. We're just simple-minded. The larger the change in the brain, the more likely it's able to yield a useful medicine. At 6 hour time point, gene expression is way down, but still there's 17 left that overlap the front and the back of the brain, and now we've gone to 17 candidates out of 1,200 genes. And those are targets for the hard work. We're now looking for a molecule that generates positive social affect, and the first molecule was insulin-like growth factor 1. We measured the protein that's manufactured from the gene, and the protein was diminished by play. So play used up this potential happy molecule. At 6 hours, the protein was up. Gene expression was up at both time points, but it was used, and it made up completely for the use within 6 hours. So we ran studies asking, will this increase chirping in rats? And the answer was, yes, it does. It's a happy molecule, to say it in short. This could not be a target for drug development because this growth factor elevates tumor growth. So you're not going to use it. There's too many potential problems. So we went to the next one asking exactly the same question. And the second one was a modulator of glutamate, the most powerful excitatory amino acid that participates in every emotion. But there's no way to tune that receptor gently. Fortunately, we had a molecule for a gain knob, not the direct receptor, but like on your audio machines, the volume control. And we could either tune the glutamate transmission up or down depending on dose in a glycine receptor. And we developed the molecules that could work on this receptor. Initially, they were polypeptides that had to be given intravenously, and they were turned out to be totally safe molecules in the animal toxicology. The human toxicology, we went to such doses that they told us we have to go no higher. Okay, no problems were seen with massive doses. And this was published last year. And the molecule that we're using is GLIX13. And here you can see this molecule increases happy sounds in our assay. And a blocker of this glycine receptor diminishes happy sounds. So glycine, GLIX13, has been in human testing for almost a year, which is phase 2 in the American system, which is proof of concept, which costs $16 million, which means that you have the venture capitalists that purchase the rights to this molecule that has to be injected intravenously. Would they buy rights to a molecule that you have to inject intravenously? No way. But our structural biochemists had generated orally available molecules for exactly the same receptor. So that is a marketable molecule. Whether it is producing antidepressant effects in humans, we'll know in about a month. But even if it works, it's a matter of phase 3. The venture capitalists have to say, we can make lots of money on this. Then they'll support that phase. Let me jump up to the other most exciting idea, which is taking the seeking system, which looks like this in the rat brain. It's enormous. It has every chemistry in the brain. This is called the reward system. Kent Berridge calls it wanting. Wolfram Schultz call it reward prediction error, and I call it seeking system, seeking foraging system. They're all in the right ballpark, but this is a good name for the primary process. This is a good name for the next process, which is learning and memory. And this is a pretty good name, even Mark used it, for tertiary process, what the higher brain does with us. You have to look at the mind and the brain in an evolutionary layered way, with a lower part of the brain controlling what the next layer does, namely affect controls your learning and memory. And then once you have these learning and memory things that have transpired, that can be delusional, as Mark was emphasizing, for all of us. And once they're there, you can have ideas that are really flaky. So Mark and I are really hoping that our ideas in this area are not really flaky, that they are really on the right track. But the fact that it requires a 180-degree shift in thinking, in neuroscience, psychology, the whole thing, it's going to be a hell of a battle. And I'm not going to be around to see that battle won. And I sure hope that Mark is alive to see that battle won. Why? I have been fighting that battle for almost 50 years without great success among my neuroscientific and behavioral neuroscience colleagues. But in Bonn, a neurosurgeon and a neuropsychiatrist have taken this idea seriously, that depression emerges from separation, distress, panic, getting too much and suppressing the seeking urge. So if this gets too much, you have depression, and when this gets too little, you get even a worse kind of depression. So you try to increase this with deep brain stimulation right in the seeking system. Only of those people who've gone through every treatment available. They have to have gone through electroconvulsive shock. And Mark and I just stopped in Bonn for a night to discuss how things are going. They have done 7 patients. 6 of the 7 have shown dramatic antidepressant effects from just stimulating the seeking system. Now, this is also Thomas Schopfler, the person that started stimulating the terminal fields, namely nucleus accumbens, and found antidepressant effects. Thomas says, I'll never go back to up there because the effect down below in the primary process part is much stronger. So, if we take these emotions seriously, and this might be the visualization of the human seeking and panic system, the seeking in green, the panic in yellow, that you try to reestablish homeostasis with a pacemaker. You know, people told us it's going to be scary. You're going to be producing mania. You're going to be producing an addictive urge. Well, it hasn't happened. And the people have never described pleasure in the pleasure system, the reward system. What they report is a renewed interest in the world, which reflects their renewed interest in life and being kind of a productive person with the right emotional energies. So thank you for listening, and maybe a couple of questions. Thank you.
So thank you so much, Professor Jaak Panksepp. And we are so happy to be supervised by you and Professor Kenneth Davis, who is also here today for our cross-cultural affective neuroscience research with Istanbul Afektif Neuroscience Research Group and Kyoto Neuropsychoanalysis Study Group, who is also here in Istanbul. Now we have 10 more minutes for questions, and then coffee break.
Thank you. So fire away. Otherwise, I'll show more slides. Well, I did kind of suggest that it requires a long conversation. It is really a primary process system. And, people that take us into love territory, they're not talking about that love, is also full of the potential of pain at tertiary process levels and, all the complexities of relationship and what you really need to do to have a lasting relationship. So love is a very high order concept. It certainly requires support from the molecular structure of the instincts. So it requires the care system. Love without care. And we know that oxytocin is a prime player in maternal care. Maternal care is a foundation for empathy. It's a foundation for a cohesive society. It provides something psychological, and my best guess is confidence, because that's really what a mother needs in the wild. That confidence allows her to do things that might have been unimaginable before. And we've tested this idea. The other idea would be that it just feels socially good. And we tested that idea and it failed miserably. Namely, you ask if you have two areas of a room, different designs, one area you get oxytocin repeatedly, the other placebo equal number of times. The animal should love to go to the oxytocin side. The answer is no way, Jose. It just doesn't happen. Why has it been around for, a quarter of a century on radar folks like me, and there is no research like that really is compelling. And we just shook our heads and said, it's got to produce place preference. And then we put an animal, a companion, on the oxytocin side, and we know that if there's another friendly animal, that produces a socially induced place preference. And lo and behold, oxytocin appeared to increase socially induced place preference, which is much nicer. Namely, it is a gatekeeper for the affective system, and I think the affective system is really the opioids. And a fellow in Hungary has been showing that oxytocin has a remarkable effect in the brain of maintaining the sensitivity of the opioid reward system in the social domain. So that opioids are carrying the hedonic message of many things, especially social reward, and but oxytocin by itself sustains that and supports that, but does not do it by itself. Yes, I think it participates in social learning very much. So if you have had oxytocin blocked in your brain, you don't develop social memories as well. So it has that associative component where, the whole package is allowing a positive social memory to guide behavioral choices. But it needs support from other molecules, which is not unusual. It also increases female sexual pleasure. It looks like Freudian theory was right, that many aspects of our social behavior may be related to basic lust issues, sexual issues, and that the social bonding molecules and the social bonding attachment systems emerged from sexuality, a more reptilian sexuality. That's a rather beautiful image of who we are as creatures. Yes, yes. Well, I think that learning operates in the brain through a principle that is properly called the law of affect. In other words, the molecules of affect are able to have an effect on the synapses that famous researchers like Joe Ledoux with fear conditioning have shown increase the connection between a predictive stimulus, a conditioned stimulus, and a conditioned response. Okay? But he has not worked out what the mechanism is at that synapse. That's pretty much a mystery. Everyone agrees it's glutamatergic. My hypothesis would be that the actual unconditioned response system, which they ignore completely, as if it's just an output in the brain, whereas in fact it's an integrated process of the brain, that this integrated process does the neurochemical magic that allows that synapse to become more effective. Our specific hypothesis is that AMPA receptors, the glutamate NMDA receptor, increases penetrance that we call learning. We think that the emotional molecules are activating AMPA receptors into the synapse that convert a well-known thing called a silent synapse into an active synapse. That's very testable, and no one has yet even thought of it as far as I know.
Yeah, I would say silent networks.
Yes, silent.
Networks,
Yes.
because synapses are very important, but they are not doing the brain.
Yes, yes,
Networks.
yes, I agree.
Very important networks
Yeah.
are shaped,
Yes.
or the behavior of the networks are shaped, according to several studies, by a web of neurotransmitters
Mm-hmm.
and oscillatory processes
Yes,
that can be also defined as unitary processes.
yes. At a functional level. Yeah.
Yes,
Mhm.
it's a functional
Yeah.
level.
I agree completely, and every once in a while I lapse into the terminology that is inappropriate, namely at a too granular a level. Psychology has to be linked not to the neuron doctrine, it has to be linked to a network doctrine. We do not have good measures of network activities except two. The best measure is instinctual behavior itself, because you can see it, and we've validated that neural circuitry is affective, rewarding and punishing. The other is the proper kind of EEG work. Now, that is still the only brain imaging that is measuring neural activity, as opposed to a secondary ghost of neural activity. fMRI is a very, weak ghost. PET is a stronger ghost. Oh, I've always thought that way, but see how I lapse in my terminology. They've punished me into talking just in synaptic terms, but the synaptic one allows you the electrophysiology, namely whole cell patch clamping at the right place in the brain, where the AMPA receptor one is testable at the finest level. So here the granular view combines with a more global network view. Thank you. Oh, one more. Let's give one more question.
Animals have a consciousness state, and if so, is it similar to the human species?
Yes, it's similar, but not identical. And people want to nail me on a cross on that one repeatedly. Are you saying that animal emotions are identical to human emotions? I say, do you think I'm an idiot? Evolution is diversity. The animal research only gives us general principles. And the lower we go down, namely the primary process level, the more the principles will be conserved. At the higher level, learning and memory, pretty good translation. At the tertiary process level, it's a crapshoot. Totally. So, it's always homology and not identity. And boy, they want to force me into an identity argument. And why they keep doing that repeatedly is they like to see me stumble. So, you saw it with at the synaptic level. They would love that. Okay, now you're talking our language. Well, that's this network business. So, thank you very much.